let you get started.
There we go. Apologies there, guys. Sorry, I was muted for a second on the audio. So first and foremost, just to check, Kevin, am I coming through loud and clear?
Yes, you are.
Fantastic. Thank you very much. So good evening, depending on whereabouts you are in the world. As you can see there on the monitor, afternoon here. I'm actually UK-based, so apologies for the slightly funny accent. These things, I try not to make it too much death by PowerPoint.
Did we lose you, Mark? Hello?
Apologies, Kevin. It seems to auto-mute me. I'm having to #6 every so often to unmute myself.
Wonder which one you are. I'm not showing that it's muting.
I just get it muted out of nowhere when I'm talking. We'll give it another go, and if it happens again, investigate.
Okay.
Yeah, no worries at all. Okay, so as I say, UK-based, and apologies for the funny accent. I like this to be nice and relaxed, so if anybody has any questions, please feel free to unmute yourselves, interrupt, or obviously, if you'd rather not take that approach, then please punch a question into the chat window. And I'll quite happily answer that way. Now, I'm actually also suffering from the tail ends of a cold, so if I have to mute myself or cough quietly in the background, I will try to keep that to as much of a minimum as I can, and I'll do my best for you not to be suffering too much. So, as I say, we are a company called StorMagic. I've been with the business for about 4.5, 5 years now, and as I say, I'm on the technical side. Now, I'm going to be covering off some of who we are as an organization, where our focus is, a bit of the sales side, but I also want to get into some of those more technical details and things for you. You may notice a bit of a difference on my, that I'm far more interested in the technical ones than the others, but wherever your questions lie, please feel free to ask, and I will do my best to answer them. So we are a software-defined storage company. It's one of those terms that's been flying around the marketplace for the last 1.5, 2 years now, along with then hyper-converged infrastructure or hyper-convergence. Now, we as a business have actually been around since 2006, okay? So we've been working in this space before the name even really existed, if I'm honest about it. Now, what is our version of software-defined storage? As everybody else's kind of seems to be different things, be it that you've got some software in front of hardware storage, you've got some, SAN backend or what. We are effectively trying to be purely software and nice and simple and easy to deal with, okay? So what we're actually looking at is using standard x86 hardware, using those internal disks and making that then a highly available virtual SAN, and not just then a single physical appliance type SAN, but also then a mirrored SAN, so everything completely duplicated to eliminate any single point of failure. Now, the whole hyper-convergence thing and other of these buzzwords, what we tend to see it as is effectively back in the good old days when storage and compute all existed on those same boxes, rather than having to separate those out to give you that HA and that virtualization benefit of consolidation and migration of VMs. It's effectively giving you that same functionality, but again, back internalizing those disks within those boxes. Okay, so you've got a standard piece of hardware with CPU, memory, controller, and disk, that virtualization layer, and that nice management piece as well to keep everything nice and simple, okay? Now, whenever we're looking at these things, we want to use as little staff power, as little manpower, and we want it to just do a job, okay? You want to be able to throw it out there and forget about it until it comes 5 years' time when suddenly you have to, oh, actually the hardware's coming end of life, but it's sat there and it's done exactly what you need it to. Now, obviously, every so often, we do get these security things that come along like shell shock, and we're very quick to then remediate those, but ideally we're looking for a set and forget solution that's just going to do a job out there in some pretty harsh environments in some cases. Now, that term harsh environments is kind of where I'm coming from with that term lean IT, Okay, effectively where we've tailored ourselves for is the enterprise robo, so large-scale distributed enterprise. Now that could be retail or hotels or manufacturing or legal or whatever the term is effectively, but where they then have multiple sites around the globe, but they're looking for that potentially centralized management model and being able to virtualize those environments without it being too expensive and too complicated. Now, that same story pretty much holds true for SMEs and things as well, okay? So be it just 1 or 2 sites, again, that nice cost-effective entry point into a virtualized environment. So our product, SvSAN, is then the perfect fit. Well, why is that? We are looking to then provide this minimal IT footprint, okay? The more layers that we have in there, the more hardware, the more entities within that environment that are there, obviously the more chance there is that something's going to go wrong. Okay, so what we want to do is collapse that into a smaller footprint as possible while still providing you that great virtualization, high availability architecture. Now, centralized deployment and management, again, that comes into that enterprise robo space of being able to, the dreams of centralization, of being able to have everything under that one roof, but actually in all honesty, we know that sometimes that's not feasible, that WAN links aren't up to it. You need a virtualization point potentially out at an edge location or at an office that, again, then you can't have somebody on site to manage it. So how do we go about that now, be it with different remote management tools, VMware vCenter, Hyper-V controllers, everything else, all of these can then provide you that easy centralized management, and we then enable that at our layer as well with that software-defined storage. Now, as I mentioned, with that centralization, this then enables you to utilize poor WAN links and still be able to use these kind of environments by effectively having that virtualization point, those servers, the actual IT itself, out at an edge location, but still potentially with that centralized management piece. So as I say, a bit about the business. We've been around since 2006, and the key thing that I want to emphasize here is that our largest deployment to date is currently running in about 2,200 locations. Okay, so that is effectively a copy, a license of our software in 2,200 locations. The next one down is about 1,300. Okay, so this is a proven product being run in production today for the last, 4 or 5 years now in those kind of scales. Okay, so it is a proven product. Okay, you can see there are about 110 petabytes of data across all of those environments, and again, then across the globe. Now, those 2 biggest customers, I believe, are purely in the US, but we then have a number of other customers that are effectively then worldwide, so have then offices out in some quite obscure places and things as well. It's quite good fun. I've been on their systems to be able to try and pinpoint where that site is based on its little acronym, so MUM for Mumbai, for example, or something similar. But yeah, we are literally talking a global organization with some very large enterprise customers and a very much a growing global channel with a number of different partners and partner programs and things in place as well. So why are we that best fit for that lean IT environment? Effectively, we are affordable, and as I say, we are looking to lower that entry point, that cost of entry point into that virtualized environment, giving you that high availability, starting at only 2 nodes, 2 servers. We want to be nice and simple, easy to deploy, get it up and running, and then set and forget. Okay. Now, obviously, not only that, when you do have those management tasks, they need to be nice and simple as well. And then to be able to provide the highest level of resiliency possible with that hardware footprint. We'll go into how we're doing that as we progress our way through my lovely slide deck. So let's just touch on what the software is. Now, as I say, this is my bit. This is my the technology side of things. So please, questions and things, ask away, and I don't know, try and trip me up or something. No worries at all. So we have this product, SvSAN, that consists of VSAs, Linux-based virtual storage appliances. They are effectively like any other VM up on top of your hypervisor, but what we do is we assign them that internal or direct attached server storage. Now, be that a virtual hard disk or a direct attached LUN, so an RDM from a RAID LUN within that box, whichever is your preference. And again, one of my points throughout this is that you're going to see that there's the flexibility within the software to build the solution that works for you. Now, each of those VSAs managing that internal storage effectively then duplicates that between the two nodes with a synchronous mirror. Okay, this means that every I/O that comes down and is submitted to that box must hit the other RAID storage as well before being acknowledged back to the guest OS or the guest initiator. Now, what that means is that we can have any failure within the environment and everything will either continue to run or be restarted by HA up on that surviving host. Okay, so we have complete duplication across those two nodes. As I say, CPU in each box, memory, controller, and disk. Any component can fail and everything will then continue to run. Now, that mirror that we present up is literally a block-level iSCSI volume. Okay, so nice and simple, and that is then looped back to those same hosts or other nodes within the cluster as well. Now, one of my points with this, again, going back to that simple message, is there's nothing complex to this. We're not trying to do black magic behind the scenes. It's not, you can't share it out to that. You can't use it for this. There's not all these caveats in place, okay? It is that iSCSI block mirror, and if you want to share that off to a third, a fourth, a fifth compute-only node, by all means, great. That's what it's there for. Okay, so compute-only nodes just access the storage, or you can obviously then scale out with additional hyper-converged nodes with those VSAs on top of those as well, and share the storage out as you see fit. Okay, it's just standard iSCSI stuff that has been around for years. Okay, we know how robust it is, and this is why we've taken this choice. Now, we then have a centralized management piece, so we have plugins that sit directly in vCenter and System Center in order to be able to manage these at scale. As I say, largest customer to date, 2,200 locations. Now, the synchronous mirror that we present up is actually active-active. Okay, so any VMs on those hosts are effectively reading internally from those disks, okay, completely independent. So they will see purely internal read speed with then the writes having to travel across the back-end networking. Now, that back-end networking is standard TCP, okay, standard TCP IP. There is, again, nothing complicated to this. We're also using the standard multi-pathing tools built into those hypervisors, again, because they are proven products. They have been around for years, okay. There's no StorMagic specialist customized thing that you need to install into this. We want to be nice and simple, and as I say, using technology that has been proven to be robust. Now, I mentioned about that standard TCP networking. This is just an example configuration with that networking, okay? Because it is standard TCP IP, we can use complex protocols like LACP, Ether channel, bonded connections, 10 gig, all that good stuff. But actually, in the case of some of these SMEs and robo environments, they're actually just looking, again, for nice simplicity and, again, resiliency, okay? So it's actually quite common for our customers to just use a crossover cable, direct connecting between the two servers. Now, again, standard x86 hardware, this could just be one box on top of the other with that nice short crossover lead. It could also be nodes or servers at completely opposite ends of the building in order to put them on different power rings and, again, give you potentially fire resiliency, or even a metro cluster across campus, or even, as I say, a few of our customers and things run stretch clusters over up to around 10 kilometers of distance as well. So, again, my point being flexibility to build the architecture that you want. Now, in this environment, if this was gigabit networking, this would mean that we'd see a sequential write speed on that storage of 220 megabytes per second, roughly, okay? That is because we are aggregating that bandwidth between those two links, okay? We simply see two separate interfaces, two IP subnets to pipe that traffic over. We could then add a third, a fourth, a fifth in order to be able to scale that up. Or, as I say, because of that crossover, even 10 gig networking becomes all the more affordable as well. Now, the reason that I'm referencing this in part as well is because it gives you complete resiliency over those links without the needs of additional switching. And obviously, if you're then looking to do this across, even 100 locations, the cost of a switch into each of those sites could potentially blow the budget. Okay, so you want to reduce that down. You want to be as lean as possible and as simple as possible. And this is then a ways to do that. But as I say, you can utilize the architecture that you see fit. Another retail use case that I quite like is, again, a company in the US. They are limited to 100 megabit networking out of those stores because that's the switching environment that they still have out there. Now, they'd looked at other platforms and things, just not feasible. But again, because of this crossover interface that they can configure, this crossover architecture, they could then introduce a software-defined storage, highly available storage solution in order to provide their store resiliency. So they were obviously then extremely happy with us as well. Now, we've designed the software to be as lean as possible, as small as possible, because we don't want to take up half of your host resources doing all these fancy things, that you may not necessarily need, okay? So we are extremely small, leaving your host resources free for your guest applications to do their job, okay? We assign 1 vCPU, a gig of memory, and obviously then we've already discussed the networking, so extremely lightweight, okay? We have this running on, 2U, 4U boxes with all this hardware in the world, but also down to, in a Lenovo config, as small as an RS-140, with a 4-core CPU, and then, tiny amounts of memory and just a couple of disks, okay? So this can go all the way from mirroring, 80, 100 gig, if that's what the customer requirement is, all the way up to terabytes and terabytes of data. So whichever, again, fits their use case. Now, I've just going to see a question come into the chat there, so thank you. I'll just touch on that, and then we'll carry on just to keep things interesting. Now, if we have multiple disk failures on one of those hosts, because everything is effectively their network RAID 1, what will happen is the VSA on that failed host continues to run and marks its side of the storage as failed. Now, this is actually something I'm going to touch on in more detail in a later slide, but effectively the I/O will then be proxied over to that surviving VSA, and if the host continues to run, if ESXi is still running, those guest VMs continue to run from the storage in the surviving host.
Wherever you are with the HP Elite tablet. Built with the power of an Ultrabook, this highly mobile device is designed with durability, security, and manageability in mind. Ask your...
Sorry, Kevin, I take it you're hearing that as well?
Yes, I am. We got a few people that aren't muted here. I'm going to...
Work your way through, no worries. Okay, it sounds like that's gone quiet. I'll continue, obviously. Yeah, please interrupt. So basically, the VMs on that failed host will continue to run from the storage in the surviving box, as long as the hypervisor continues to run. Obviously, if the hypervisor was on that failed storage as well, then that host is as if it is a complete host outage, like a cable pull. It goes down, and you get your guest VM restart. Okay, so how are we doing then that 2-server configuration, and how would we then scale out beyond that, that I'll go into in a bit of a minute. So this is this 2-server architecture, and this is what we typically see in those large-scale robo environments because they are looking for that very small footprint, okay? Now, effectively in this case we've got, for example, that 2,200 site customer, 2U standard x86 servers, and a VSA on each of those. Now, what they then also have is an arbitrator service, this little black box that you can see at the top there, called that neutral storage host. Okay. Now, in their case, what they do is they run that in a centralized location shared between all of their different sites, okay? So for 2,200, I think they run about 6 NSH appliances effectively based on geographic location, okay? That's not a software limitation, that's based on their manageability and how they wanted to organize things. And again, all of these are just options. You can build the architecture that works for you. Now, when you do this kind of synchronous mirroring, typically you look for this logical triangle that we're effectively building out here. There are some other software products out there that are entirely reliant on the hardware in order to be able to provide that. So if all the links between those two nodes go down, if you have a switch or network failure within that environment, the data sets will diverge and you are at risk of data corruption, okay? There is no quorum element to it. Now, we can run like that. However, it is certainly not recommended, and this is why we have this arbitrator service, and you can see with some of the statistics here as to how resilient it is and what it effectively enables you to achieve. Now, this service effectively distinguishes between nodes being offline or just isolated on networking effectively. Now, we can see there with the latencies that it can withstand, 3 seconds, 3,000 milliseconds, that he could exist anywhere in the world. He could even exist on the moon, and all of this would continue to work. Now, 9 kilobits of bandwidth per SvSAN mirror also then mean that in your centralized data center or location, if that's the way you're looking to do this, it's not going to chew up all of that site's bandwidth in order to be able to manage multiple clusters. We can also see there that you can also share this between thousands of locations, even just a single one. Now, typically, with that quorum logic, with that logical triangle, what you look to do is to be able to tolerate one failure. As soon as you have a second, the remaining device is unable to determine its state. It doesn't know if it's isolated or if the other two nodes are actually offline, so it takes itself offline for safety's sake, to prevent any data corruption. Okay. Now, in order to centralize this quorum service, we've actually modified that logic slightly to provide even further levels of resiliency. Now, if I lose host 1 in this architecture, for example, I'm on site and I manage to pull a cable or pull a power lead out of that box goes down. Well, great, everything's fine. I've had one failure, no issue at all. However, while that host is down, if my WAN link were to then blip with that typical architecture, that remaining device would go offline. Now, with us, this is what has changed, okay? That surviving node keeps itself online. It knows it's the last synchronized data due to the order of the failure. So if I lose a host, then my quorum service, he stays online. He knows he's all good. Now, the alternative to that is to lose the quorum service first, then the VSA, at which point we're also unable to determine state, so we take that data offline in order to be able to protect it. Now, because this is an appliance potentially up in your data center or even up, unlikely that he's then going to go down. He could be HA or even fault tolerant himself. So resiliency with a very, very small footprint at your edge location. So these extremely lean. We could be talking a tower, a small rack, or even building up to something 650 with a lot more disk and things in as well. Now, that's fine, and if you want to share that out and run that model, great. That quorum service could also run on as small as a Raspberry Pi, stuck to the front of one of those servers with a bit of chewing gum, okay? It's extremely lightweight. It could exist within the environment or remote to it. It is just a service, and again, there's a lot of flexibility around that. So what my point is that you can build the architecture to suit you. Now, this means that in the case of that 2,200 site customer, they had exactly the same config for all of their sites, so they knew exactly what they had. But for alternative cases, site 1 might have completely different needs to site 2. However, with our software, you can then build an architecture that works for each of those locations. So if site 1 only needs, a few thousand IOPS, no issue at all. If site 2 then needs, 5,000, 6,000 IOPS, well then, build that higher spec server, that higher performance servers, and be able to provide that and that customization based on the site requirements. So you can build it as you see fit with standard hardware, okay? This is stuff that you all know. There's no mysterious behind-the-scenes things. This is standard hardware that you get to choose and configure based on your requirements. So effectively, my nice little animation, I lose a host and my VM fails over, much in the way as I say, if the hypervisor was on that box on that storage, he goes down, the VM fails over, or alternatively, if the hypervisor in that instance was on an SD and the storage in that box failed, well, the I/O would just get proxied across because everything's continuing to run. Now, the VSAs themselves, as I say, are extremely small, extremely lightweight. They literally consist of a 512 meg boot disk and a 20 gig journal drive. Now, they also then pushed out via an OVF image, about 110 megabytes of data per appliance, okay? So this means that you could actually stage this, pushing it out over WAN links to a remote location, or you could have a lab environment, get everything set up, and ship those servers out at a later date as well. Now, this could be coming in at a hardware refresh time. It could also be using existing hardware that's out there in production as we speak that isn't virtualized or is virtualized and running on local storage. We can easily introduce the software into those kind of environments as a staged configuration. So get the one box set up, migrate your VMs, and then synchronize across at a later date. Or for example, if some of your customers or some of these businesses and things have a single node out there, but you're having issues or you have concerns that that box may fail and put that site offline, well, by all means then introduce a similar box and be able to synchronize across and introduce that high availability. Now, not only that, this means that actually you could run disparate hardware within those environments. Now, obviously as a hardware refresh, you're going to introduce exactly the same hardware, just again because it's nice and easy for those two nodes. But if, for example, you had some existing hardware out there and you want a second box, by all means, no issue at all. So if you've got an RS-140 and then you're looking at a tower, or you've got a 3250 and you need a bit more compute, so introduce a 3550 with a dual socket instead, by all means, okay? all we will do is network grade 1, synchronously mirror that storage, and everything else, we don't care, effectively. Again, nice and simple, and build that architecture that you require. Now, the centralized management piece that we then have is that we can integrate very closely with VMware vCenter. We've got different plugins and things that sit within there in order to be able to enable that deployment, nice, easy wizard-based deployment and setup, but also then for ongoing monitoring, we've got a dashboard that will monitor all VSAs managed by that vCenter. Now, this means that you can very quickly and easily overview the environment as a traffic light-based system. Okay, so red, yellow, green, nice and easy, with the different events and statuses and things being triggered based on different events within an environment. So, for example, one node is offline, so we've got a site there in a warning configuration. Because everything's okay, we're just unsynchronized. Actually, we've then got another one there that's in an error. So, for example, he's quite probably had an underlying disk issue and has actually got storage failed. So you would then need to go in and potentially remediate that hardware and just check out those disks and things from your hardware vendor. Now, this enables that easy, remote, simplified management effectively. Now, monitoring, obviously we've got that dashboard that sits there as well, but as I say, when we've got customers managing 4,400 plus of these things, you're going to need to be able to monitor them easily, which is where their dashboard comes in, as well as then alerts and notifications as well. So SNMP, SMTP, and vCenter event forwarding are all then fully available to you. So effectively the appliances will push their events up to your vCenter. So again, you get that nice, simple ease of management and notifications that they're going to pop up in your usual management tools. Now, not only are we then able to do all those tasks via our different GUIs, but obviously if we're then looking at doing this at scale with potentially thousands of these things, you can script everything as well. So we have a full PowerShell commandlet library that enables you to script out every task that you would want to do with the VSAs effectively, from deployments to upgrades to mirror breaks to whatever it is that you need to do. So, for example, there are I mentioned about this brownfield installation, for example, getting one node set up, migrating and then synchronizing at a later date. You could also, on an existing mirrored environment, carry out a staged remediation, break that mirror, take away that host, replace it with another piece of hardware, and then synchronize across, okay? We give you the granularity, the visibility, and the control as an admin to be able to do the tasks that you're going to want to do with these kind of environments. Excuse me. Right. So, forgive me. What we also recently introduced into this to be able to further accelerate I/Os and potentially then reduce that per site cost is an SSD caching module. Now, we're obviously all aware that then flash-based storage is coming down in price, but if we're talking then high capacity stuff, it can still get quite expensive. So what we have done is effectively have a module that then manages either a single or more SSDs within that host, so that those I/Os are then acknowledged up to the guest OS to then be sequentially written back to some larger capacity, slower magnetic storage at a later date. So you can very easily build out potentially some large capacity slow SATA disks to be able to hit capacity requirements while still being able to have those performance needs held up by the SSD. Now, as I say, that's there to reduce that per site cost and can be done with as small as a single SSD per host. Now, it could also be a flash-based RAID set, but because we have this mirroring going on, effectively the I/O will hit both of the SSDs. You can get away with a single disk within that box to be able to accelerate these environments. So, I mean, as a minimum, you could even come along and have a single magnetic disk and a single SSD. Okay, obviously, if you want the inbuilt resiliency within the hosts as well, make that a RAID 1. But you can see how small a footprint that you can then build out that you can still have this highly available, high-performing environment. Now, as I say, those I/Os will then hit that SSD, get acknowledged back, and then be write coalesced and sequentially written back in 1 gig chunks at a later date. But that is a write back cache, okay? So the I/Os are not actively being brought up into the SSD. So effectively what we recommend is a cache sizing, and this always gets a little bit complex, but effectively around 1 day's worth of I/O change in an office environment being able to be held within that cache. So this means that typically typically that's not quite the order that I want them in. Typically, we'd recommend around sort of 250 to 512 gig of an SSD per box in order to be able to hold that I/O, and it also means that the larger the cache, the more read hits that you're going to see, because after they've been sequentially written back, they will continue to exist within the SSD to then be read back. So you will see a good level of read I/O acceleration as part of this as well. Okay. So effectively then, the cache is assigned to each of those VSAs, and as I say, those writes hit each of those SSDs, so you get that resiliency across those nodes that even one of those SSDs could fail and everything will continue to run. Now, the SSDs themselves are not actively mirrored, so they could have different data within them from what's been written back and what's still been held and overwritten and everything else, but the I/O will guarantee to hit both, so you get that resiliency. Now, effectively then, the I/O hits that disk, gets filled, and then effectively pushed down to a flush queue, and then written back to the magnetic disk, nice and easy. And you can see there from the different segments and things that we have that we've got dirty, clean, and everything else, and you're going to get a good level of tracking. So you can see there read hit, read miss, etc., etc. So that's where I want that one. That's going to give you the kind of statistics and latencies and things presented up into the GUI as well that will show you the kind of information that you want. Now, this is also true of our regular targets as well. So you can monitor these environments very easily and export these kind of statistics and things as well. So should you be experiencing an issue with a site, then you can get the tasks and tools that you need. Now, as I say, sizing, you can have a much smaller SSD, but as I say, we'd recommend about 250 gig. And we can also see there they're effectively using a binary tree, so that so it's nice and efficient on the memory usage. However, I mentioned about 1 gig per VSA. If it's utilizing caching, we then just recommend 2 gig. However, as I say, that is still extremely lean in comparison to a lot of the other products and things that are out there at the moment. Now, the NSH Appliance that we then have available to be shared out and essentially arbitrate all those potential locations, or even have multiple of them existing, one per site, again, is extremely light. So we're talking 512 meg of memory and a gigabyte of hard disk. So again, all of this is there to be nice and simple and easy to manage, just a single IP in this case for all of those thousands of locations if you're sharing it, and extremely lightweight on all of your hardware. Now, we had the question earlier about disk failure. Now, the VSA is, as I say, effectively running a Linux kernel. Okay, we started out as Red Hat, but things have obviously been kind of customized since then that we now just say a Linux kernel. It's also a in-house custom-written iSCSI target. Now, effectively, we looked at some of the open source ones that were out there when we were first developing this and found that they didn't do what we were going to want it to, so effectively they made their own. Okay, so it's all then very nice and, as I say, very resilient and robust and does what we need it to. Now, because we're then that Linux-based VM, it means that you can then manage that box nice and easily with the different GUIs and things, but effectively you can then modify that as well. Okay, so it doesn't appear as a specialist VM. It is much like anything else. So you could add additional network adapters, SCSI adapters, as you see fit down the line if you wanted to modify or upgrade an environment, for example. So say you had a 1 gig backend link, you wanted to add a second, great, no issue at all. You literally just add the NIC, add the interface to that VSA, and away you go. Now, we can also then manage different storage types, different RAID LUNs. So, for example, a SATA RAID set, and then a SAS RAID set, and then your SSD cache in front of it, for example. Again, no problem at all. So, that's just going to appear as an additional device on the VSA, an additional PV SCSI adapter writing down to a disk. Now, we have an I/O timeout built within the software of 60 seconds, so this is obviously then very large in a storage environment, but effectively what happens if we then don't see responses from the I/O timeout plex or a side of the mirror, we'll go into this not responding state. Okay, so everything continuing to run from the good side, but this guy's having issues, be it that controller's locked up or the disks are having issues, so he's then marked as not responding. He'll then be there retrying that, and if it isn't able to come back and respond, then it effectively gets left in that not responding state and continuing to retry. And when things are then all okay and completing again, the state gets automatically cleared and automatically synchronized. Now, if we get I/O failures down to that device, or if they time out beyond that certain threshold, then that Plex gets marked as failed. Now, that failed state is then always a manual intervention in order to be able to then recover that. So you can obviously then investigate the control of the disks, look at the logs and everything else as to what's going on, but it's then an operator that has to come in and be able to go, right, clear that, it's all in a good state, and we'll resynchronize that across. Now, I mentioned earlier about this 20 gigabyte journal drive on each of those VSAs. Effectively, what happens is when one of those nodes is unavailable, we're tracking metadata changes within that disk so that when it does come back up, we can do a quick resynchronization of the data. Now, that is then same true for that not responding state, so we'll do a quick resync. It's purely the block changes that will then get piped across. However, once it's gone into that failed state, we've had I/O failures. When it is then recovered, we'll do a full synchronization of that data set from one side to the other, just to guarantee that data integrity, make sure everything is in a good and healthy state. So as I say, what it's there to do is to let you build in extremely high levels of resiliency to these environments. Okay, it is effectively that layer between your hypervisor and your storage to give you the resiliency, the duplication, and even be able to tolerate then those underlying RAID issues that you would potentially see with a single SAN appliance. So for example, that 2,200 site customer was virtualized prior to us being involved. They had 2 servers and a small SAN in each of those environments. They were seeing in the region of about 30 failures a month, be it due to networking failures, power outages, disk failures within that SAN. They had resiliency on the compute, but that SAN was then a single point of failure. So they then looked to ourselves to be an alternative to that, and they now have a pair of 2U boxes in each of those locations, our software providing them full resiliency across the 2 nodes. So where does Lenovo come into this? We've partnered very, very closely with them in the last year or so, and effectively built out some soft SKUs, or some, just some rough entry point type servers that are there as a starting point for any designs and things that you might want to look at, such as then small 1U boxes in the case of the RS140s or the 3250s, or even then some beefier hardware like that RD650 or an X3650 if you want to go towards the higher end. Now, be it a Think server, be it an X series server, we don't care, we can utilize it as long as it's then on the hypervisor's HCL. Now, each of those has their own benefits, be it that they are a very small entry-level solution, nice and easy, nice and compact, or, as you see with the RD650, that actually you can mix those 3.5-inch and 2.5-inch disks. So something like our SSD caching becomes then a very nice fit for that, with then, for example, some 6 terabyte SATA disks in those 3.5-inch bays, and some flash disks in those 2.5-inch to be able to provide you a high-performance, high-capacity environment as well. So we are seeing some success, or a lot of success, in a lot of different verticals. I've mentioned some of them in the way of retail and legal and government and things like that. Legal have been various law firms that are effectively running our software with their own applications on top of us. I mean, the typical type of applications tend to be small to middling I/O workload, potentially then with some higher compute if they're looking to build that in. But the key thing here is resiliency and high availability. Now, as I say, those 2 largest customers, both in the retail sector, but energy like oil and gas out on some oil rigs and things, as well as wind farms up in Canada and across Europe and such as well. Again, where applications that monitor those turbines and everything else within those environments and pipe that data then back up to a centralized location, but they need that high availability because they can't just send someone out into the middle of nowhere to a wind farm in order to bring a box up, in a matter of hours. It takes days or even weeks in order to be able to repair these things, so they want that level of resiliency that we can then introduce. Effectively, you know, the application that sits on top, you build the number of disks underneath that are going to be able to provide those IOPS. So again, technology and principles that you've come across many, many times before. So just some of our existing customers, as I say, Eon, Climate and Renewables, that's those wind farms and things. SafeKick, we have a case study on both of those that I'll come to in just a second. Some of those oil and gas, Overweighty being then a supermarket chain. But as I say, those key points being, you know, high availability and resiliency. So why look at something like ourselves rather than external SAN? Effectively, you're going to reduce single points of failure, you're going to reduce complexity, reduce the networking requirement, all of which is going to bring down that CapEx cost, that initial outlay. Now, not only that CapEx cost are we talking about, but also the ongoing things of power, cooling, and managing those types of environments. Okay, so obviously with that single SAN appliance potentially out there, if it does have an outage, obviously it's going to cost you money, but also then managing it. So if you want to be able to do firmware updates to it, or as I say, when the shell shock security fix came out, for example, you had to take the entire environment down rather than being able to do that as a staged, non-disruptive process. So it's all going to have, you know, those ongoing costs of power, cooling, and manageability, as well as just that initial outlay, but also then space reduction as well. So, you know, we're freeing up rack space, or even, as I say, being able to shove a couple of boxes underneath the stairs, for example. So typical reasons for looking at customers, looking at our software: limited WAN connectivity, potentially down to speed, latency, or even then PCI compliance. So a number of our customers, the data has to exist within certain physical boundaries as well. You know, limited IT resource, potentially lack of local IT skills. So effectively, they're looking to farm out that a managed service provider, effectively just you know, providing those servers leasing to be able to have that same virtualization benefit at a good price. So, IT resiliency, you know, multi-site rogue, or even just a small single. So effectively, that's us. I mean, we're there to eliminate downtime by duplicating everything across those two nodes, eliminate a single point of failure, and also then be able to eliminate not just that unplanned downtime, those failures and outages, but also then the ongoing planned downtime, as I mentioned, with firmware updates or expanding RAID sets and being able to expand these boxes and upgrade paths to be scaling up within those hosts or scaling out to other nodes as well. Gives you that additional flexibility, and all on standard hardware. Okay, so we all know how good Lenovo hardware is, being able to utilize that to be able to provide you the same benefits. Essentially deploy and manage, and also then those ongoing cost savings that we mentioned earlier. So I just wanted to go into a few case studies of existing customers, one of which is then the Wisconsin courts. Now, they actually use 3550s, so there's dual socket, 1U boxes, so a nice small footprint with while still enabling them to have that high compute and high I/O environment. So they're using a pair of those in each of those locations for on-site applications, but also then for the record audio recordings and things as well. So obviously they need to hang on to those for X period of time for their own compliance reasons, and they need that to then be always available to be able to run and to be able to do their jobs effectively. So that's about 75 locations across the state. Now, this is then that 2,200 site customer. As I mentioned, their experience was that they'd gone through that virtualization project, they had that SAN out there, and they were still experiencing issues, you know, outages, and not only that, but data loss as well. So be that from RAID failures or controller outages and issues. So it started to cause them quite the headache. You can see there are about 100 store outages per year, and I can imagine that was costing them substantial amounts of money. You know, they were looking at alternative products, and effectively then were, after that high availability, reducing that infrastructure that was out there and to reduce that ongoing complexity. So, I mean, I think now for the 2,200, they have about 3 guys that manage the entire environment. Okay, so it is extremely easy and simple for them to manage their ongoing tasks. And obviously then, by introducing ourselves, because they were able to reduce that 3rd node, so go from a 3-node virtual SAN type solution down to a 2-node, they saved 30% on hardware just by losing that third node, being able to run the 2-server architecture that we showed you earlier. Ongoing costs of manageability, and then that 2-server environment out there at the edge location. Partnering with VMware, they get all that good vCenter integration, single pane of glass management, and being able to easily maintain and manage these environments with the different scripting tools that we're able to provide. It also gave them actually an increase in performance because they've been previously limited by gigabit networking by internalizing those disks. And in their case, they had a couple of 10 gig back-to-back connections. So they actually were able to achieve then a very high performance environment, again, very cost effectively. By having some fast disk and that fast networking. And not only that, it's then scalable for them as well. So, if it comes down to it that, in 5 years' time they want to swap out the hardware vendor or, expand beyond those 2 boxes, introduce something else, because they've made that investment with ourselves, they're then able to do that quickly and easily. Now, I mentioned earlier about oil rigs. This I quite like because it's not exactly as if you can just helicopter someone out to them very, very quickly. And as harsh environment goes, then that's pretty harsh out in the middle of the North Sea. So, again, resiliency was absolutely key to them. And in their case, they've got, I think it's just as small as 2 blades on each of those servers with then just a local quorum device providing, that arbitration for that mirror. And, that is then similar to the Internet of Things model, so effectively monitoring all of those different pumps and servos and different bits and pieces that are on that oil rig to be able to make sure it's working efficiently. Now, not only that, it also gives them the ability to do predictive failures. So they monitor these at all times, literally every second or 2. They're monitoring what the responses are from this, so that it comes down to having to send divers down to be able to replace a piece of kit. They can preempt it rather than it being taking an oil rig out of action and being unable to operate, or something exploding and causing damage along the way. So you can imagine as to how key that application is and how much they wanted that uptime for it. So even though we're talking very tiny measurements and everything else, it's effectively an Internet of Things type model to be able to monitor something as important as oil rigs out there. Another nice, again, we're all about the high availability and all that, is the German army. Now, they're actually using ruggedized hardware, but effectively just there in this chassis rack that can be sitting in the back of a Humvee or thrown out the back of a Hercules jet or something, or plane or something like that. It's definitely got to be ruggedized in that case, but it enables them to then set up that highly available virtualized architecture. They can throw additional applications on there very quickly if they need then some a local mapping resource or something like that, and that they can throw out these battle operations sites very quickly and easily. But as I say, I mean, if you're talking high availability and uptime being key, then a battlefield is a pretty good use case. And then finally, our last one, you can see, sorry, we've got a number of these. The energy company that I mentioned earlier with these wind farms, as renewables and green energy and stuff becomes all the more key, being able to reduce those ongoing costs, those energy costs of having this hardware out there becomes key, but also then, generating this in the application and stuff that it uses, is extremely important. Now, in their case, as I say, much like the oil rigs, there's no on-site IT. You can't quickly get someone out there. You can see there it takes them about 6 days to be able to get an engineer out to be able to get something fixed. And not only that, it was a very small environment because we're literally talking at the base of a wind farm. So, yeah, very similar type of thing. High performance in their case for production, for the type of environment that it was. But again, by internalizing that disk, they were to be able to build that out very quickly and easily. So what can you guys do if you want to actually try it out or learn more? We are happy to schedule in WebExes, do a live product demo or anything like that. Please feel free to contact myself or our colleagues and things. The different email addresses there, info@StorMagic, and we'll be able to get something set up for you. We've got various partner programs and things in place that you can sign up to. and become then a partner and get access to different training resources and things as well to be able to get up and running. As I say, it is all nice and simple and straightforward to use. We also then have a 60-day trial evaluation that is available and fully supported on our website. So if you were wanting to test it out yourselves or get some of your engineers and things involved, try and get them excited about it, please do, and we will happily assist as required with that 60-day free trial. Any questions that you have, we are here to assist. And then as far as licensing, as I say, a single purchase gives you that high availability across those two nodes, so effectively gives you 2 VSAs based on the mirrored capacity. Okay, so much like that network grade 1, so 2 terabytes, 4, 8, 16, and then unlimited, with the different then support offerings and things available. So everything, again, is nice, simple, and easy to use. Okay, Kevin, I think I've just about talked myself into a hole, and my throat's now getting very sore, so thank you very much for hosting me. I haven't had any other questions through into the chat, but if anybody wanted to unmute themselves or ask any questions or push those out now, please feel free, and we can hang on while those questions come in.
Thank you very much today, Mark. I really appreciate you coming on and presenting your product to us.
Well, thank you very much for hosting us. It's nice to get the word out. As I say, there's a lot of companies out there that are a little bit mysterious, a little bit black magic. We are not trying to be that. We want to be this nice, simple, easy solution. We're very easy to work with, and there's nothing mysterious to what we're doing. Effectively, we want it to be, a pleasure to work with. Effectively. Okay, so I guess we're not having any questions. It doesn't look like so far, Kevin. So,
hey, Mark. Just
hi there.
Can you hear me?
Yeah.
Mark. Okay. It says, does the unlimited license cover up to 3 hosts?
No, it wouldn't. That would effectively be 2+1, effectively. Now, I mean, our sales guys, one of my colleagues, Dan Diesso, is actually hiding somewhere here in the background. We can do that very easily, so you don't have to just scale in pairs. You can easily build a 3-node or a 5-node model as well, if that's the way you wanted to go. So, yeah, by all means, at that point, we can certainly discuss licensing and licensing cost. No problem at all.
Are there any other questions? No, don't see any. Okay. Mark, thank you. And I think you did a wonderful job of telling us about your product. So I appreciate it.
Thank you very much. Thank you very much, everybody, for attending. Thank you very much for your time. And as I say, any questions in the future, please contact us, and we'd love to help you out and see if we can work together.
Thank you, and that ends the meeting today.
Brilliant. Thank you very much, Kevin. Much appreciated.